Hello, good day everywhere you are. So today we're going to do this May-June 2022 with variant 21. So this is question 1. So in the first question we have calcium, magnesium, radium. Means that we are talking about group 2 elements, and the first question, so you need to identify the highest energy orbital in a calcium atom. So when we look at the periodic table, we know that calcium is in group 2. It means that it is in S block, and then calcium is in the 4th period. It means that the highest shell will be 4, and since it is in S block, so that will be 4s. So for any s orbital, the shape will be spherical. So next one, the decomposition of calcium nitrate. So calcium nitrate is CaNO3 2. And since they mentioned decomposition, it means that it will not react with anything. There is no other reactant, and it will form a calcium oxide with the presence of nitric ion. When we heat, definitely we will have nitrogen dioxide gas, and we will also have oxygen gas. So all we need to do is balancing. Calcium is balanced, so we need 2 nitrogen. So balance out for oxygen, we will need half oxygen gas. The next question it asks between calcium, magnesium, radium. It means that group 2, down of group 2, which one will require the highest temperature to decompose? So when we look at the periodic table, group 2 is started with magnesium, calcium, and then the last one will be radium. And as we know, down the group 2 nitrate become more stable. It means that it will require a higher temperature down the group for it to decompose, due to less polarizing by the cation. So in that sense, it means that radium nitrate in this case, will require the highest temperature to decompose. As down the group 2 nitrate, the compound become more thermally stable. Next question, so when we have aqueous radium chloride is added to sodium sulfate, just a simple reaction will happen here. So we have radium chloride, sodium sulfate together, reacting. So the anion will be swapped together. So we will be producing radium sulfate. And as we know, this radium sulfate is a solid, so it will produce a white solid. So it means that since the question only one observation, so you will see something as a white precipitate. The next one, you are given the chemical formula. So from this chemical formula, you can identify the number of proton, which is this one. This is the number of proton. And the top number here, this is the number of proton and neutron. So generally, when we minus 25 and also 12, so we will get the number of neutron for magnesium. So that answers all of the questions. So the number of proton will be 12, and the number of neutron will be 13. So for any ground state element, the number of proton will be equivalent to the number of electron. So since this magnesium has 12 number of proton, it means that it also have 12 electrons. So for any electronic configuration, we will follow Aufbau rule, where we will start with the lowest energy orbital, which means we will have 1s, so 2 electrons in 1s. And then we have 2s, 2p, so that total up to 10 electrons. So the remaining 2 electrons will be in 3s orbital. So this next question is stated that magnesium has 3 isotopes, and the information for those 3 isotopes are given, but you have a missing mass for X here. So for any definition, you can quickly refer to your textbooks where you need to memorize for you to score this 1 mark. So the next question, we need to identify the mass for X. So by now you should know that the relative atomic mass for any element is equivalent to the summation of the abundance multiplied with the mass. So let's put Z as our unknown here. So let's put here the relative atomic mass, which is 24.31. That will be equivalent to Z multiplied with the relative abundance, 78.99, plus another isotope, the mass is 24.99, multiply with the abundance C, and the last isotope, multiply with the abundance C. So since the percentage abundance is in percentage, so we need to divide by 100. So you just need to solve for Z, so key in inside your calculator, so we will have Z as 23.99. The next question, we need to state one similarity and also one difference in these isotopes. So as we know, for any isotopes, they will have the same number of electrons, however, they will have different number of neutrons. For any element with the same number of electrons, it means that they will react the same way. By the meaning of react similarly, it means that they will have the same chemical properties. And for these isotopes, since they have a different number of neutrons, it means that they will have a different physical properties. Those physical properties include density, mass, and so on. In this next question, so we have magnesium, it burns in oxygen to produce magnesium oxide. The first question is they ask about observation when magnesium burns in oxygen. So the flame color for group 2 element burns in oxygen has already been listed out. The next question asks for a reaction pathway diagram. So let's look at this reaction. This is a reaction of magnesium burned in oxygen to form magnesium oxide. So for any combustion reaction, obviously this is an exothermic reaction. So for any exothermic reaction, the reactant will have a higher energy compared to the product. And we will have a curve from the reactant towards the product, where from the reactant towards the highest hump, this is our activation energy, which the value has already been given, so we just put on the value here. While for the enthalpy change, it must be from the reactant towards the product. Since this is your exothermic reaction, so the arrow will be pointing downwards. Last question for this first question, so we have cold water, it reacts with a piece of magnesium, but it reacts very slowly. However, when you have cold water reacting with a burning magnesium, so it will react explosively. So we have learned in the rate of reaction, for any reaction when you increase the temperature, the rate of the reaction will become faster. This is due to now, and that causes more particles to have a higher energy compared to the activation energy, which is the minimum energy required for the reaction to happen, which in then lead to a more successful escalation. So that's why the rate is faster.